moving on the our pathways, direct pathway or an indirect pathway. So we can think like there is a two highway inside the basal ganglia. There is the one is a direct pathway or another is the indirect pathway. So the direct pathway we have also discussed. There is estimate go action or start initiation. So moving on, when anything like we think to the move our arm or anything or any body movement, so there is a motor cortex, and that think to do this movement or that excite the stratum. When the stratum is excited, that inhibit globulus pallidus internus and their reticularis reticulata, sorry, this substantia nigra reticulata that inhibit, so making with the another color, that inhibit the globulus pallidus internus and the substantia nigra reticulata. So this globulus pallidus internal is work as a break when it's inhibited, so brake is off. When brake is off, that it means that it's stimulated inhibited, so it's sent to the impulse to the thalamus. So it's inhibited, so there is a thalamus, and the thalamus sent to the impulse excited symptoms impulse to the cortex to do movement. So start movement. This is direct pathway. We can look in this image also. This cortex release the glutamate is a excitatory neurotransmitter which stimulate to the stratum. There is the caudate and the putamen, and the caudate and putamen secrete the acetylcholine local neurotransmitter, and when that is stimulated to this nerve, this is the GABAergic neuron which inhibit the globulus pallidus internal and substantia nigra reticulata. So when it's inhibited, that also inhibit less release of the GABA, that also there is a less inhibit this neuron, and this is also GABAergic, so inhibition of this neuron. So it's the thalamus, there is the thalamus has a stimulation, and that less GABA, so it's as a work as a brake. We discuss as a brake. When there is no brake, so the thalamus stimulates the cortex, and cortex fire the movement. This is the direct pathway. So there is another is indirect pathway. It's help to the stop. So for the stopping, there is some unnecessary movement going on. So the cortex have stimulated to the substantia stratum. There is the caudate and putamen. So this caudate and putamen or stratum that release acetylcholine to the external globulus pallidus external, and the globus pallidus external inhibit to the subthalamic nucleus, and when the subthalamic nucleus is inhibited, so that secrete the glutamate. When glutamate go and stimulate to the this internal and reticulata. So this is when this is stimulated, that release GABA more, increase GABA, that inhibit the thalamus. When thalamus is inhibited, then there is the when thalamus is inhibited, then lead to the as increase the glutamate of the cortex, and that decrease less amount of glutamate, and that lead to the cortex and to the impulse to the stop the movement. And there is another that is known as substantia nigra, and substantia nigra has a dopaminergic substantia nigra, and this is the compacta, and it's secrete dopamine. Dopamine is a modulator, so it stimulates this and this modulation. There is the two receptors. I am going to draw another image. So there is the from the compacta substantia nigra compacta, and this go in the direct and indirect pathway. So there is direct or indirect. This is the direct pathway and this is the indirect pathway. Go to the thalamus. So in the direct pathway there is a T1 receptor, and in the indirect pathway there is a D2 receptor. So like when dopamine go in the direct pathway, so it stimulate or synapses to the go activates, but when go in the D2, so it's inhibit it still go inhibit. So overall the dopamine modulate make move to more, like when it's inhibit the and there is no any jerky movement. So this is the dopaminergic pathway. And when we look embryologically, there is some development, so I am not going to discuss regarding these things. So I am going to discuss briefly in that about the diseases. So there is a Parkinson's disease. There is a Huntington disease. Then there is Hemibellis condition, Hemibellismus. Then there is Wilson's disease. Then dystonia. How there is the decreased dopamine or the damage of the like substantia nigra that lead to the dopamine. So that lead to the slow or rigid, and also there is a tremor production. In this case there is at least dopamine, there is no modulation. So in Huntington's there is the damage of the caudate nucleus, and there is less GABA. It is as a work as a inhibitory. So there is not proper movement. There is like jerky and also dance like movement. So when regarding hemiplegismus, there is a subthalamic nucleus damage, a problem in the subthalamic nucleus. When its type of nucleus, there is a one-sided of the flaring movement, flaring movement. And in the Wilson disease, there is a lentiform nucleus, problem in the lentiform nucleus, and that leads to like there is a tremor or psychic syndrome, or if there is dystonia, another condition dystonia, there is the basal ganglia circuit problem or structure is affected. So there is the like twisting condition. There is like condition of twisting, repetitive movement. repetitive movement. Like basal ganglia have the stopping function, also initiation function. So there is no stopping function that leads to the repetitive movement. These are some conditions. So I am stopping this video.